Hello everyone, welcome back. So in this video we are going to learn two more differentiation vector differential operators, namely curl and Laplacian. If you are first time to my channel, please consider subscribing. So first operation is curl of operation. So in curl operation, the input is a vector quantity, so output is also a vector quantity. So input is a vector and output is also a vector. So consider a common vector a bar, which is given by au1 cap plus au2 cap plus au3 and au3 cap. So the cross product of the del, that is nabla or atled, with the vector a bar is called as the curl operation. So the cross product of del with the given vector a bar is called as the curl operation. So its formula, generalized formula, is given by del cross a bar is equal to 1 by h1 h2 h3 into h1 au1 cap h2 au2 cap h3 au3 cap dou by dou u1 dou by dou u2 dou by dou u3 of h1 au1 h2 au2 h3 au3. Okay, so this is the generalized formula for curl operation, and if you apply it to the Cartesian coordinate system, so you will get del cross a bar is equal to, since h1 h2 h3 all are equal to 1, so you will get ax cap ay cap az cap dou by dou x dou by dou y dou by dou z of ax ay and az respectively. Okay, so this is the formula for curl operation in Cartesian coordinate system. Similarly, if you apply it to cylindrical coordinate system, so you'll get del cross a bar is equal to 1 by rho of a rho cap rho into a phi cap, because h2 is equal to rho, and this is az cap. So next is dou by dou rho dou by dou phi dou by dou z of h1 is 1, so you'll get a rho, and h2 is equal to rho, so you'll get rho into a phi, and h3 is equal to 1, so you'll get only az. Okay, so if you expand this determinant and multiply it with 1 by rho, so you'll get the formula for curl in cylindrical coordinate system. Similarly, if you apply the same to spherical coordinate system, so del cross a bar is equal to 1 by r square sine theta, because h1 is equal to 1, h2 is equal to r, and h3 is equal to r sine theta, so you'll get r square sine theta. So this is ar cap, and this is r into a theta, and this is r sine theta into a phi cap. So this is dou by dou r dou by dou theta dou by dou phi. So in the last column, so we'll get ar, because h1 is equal to 1, h2 is equal to r, so we'll get r into a theta. Similarly, this becomes r sine theta into a phi. So this is the determinant. Okay, so these are the three formulas in the three coordinate system. This is for Cartesian coordinate system, and this is for cylindrical coordinate system, and this is for spherical coordinate system. So all the three coordinate systems will have the formula. So instead of remembering all this, you can remember the common formula. Okay, so next important point is curl represents the rotation or angular velocity. So curl represents rotation or angular velocity of given vector at a particular instant. Okay, so it represents the angular velocity, that is the direction of rotation, whether it is rotating in, the vector is rotating in clockwise direction or anti-clockwise direction, is given by the term or given by the operator, curl operator. Okay, so if the resultant of curl del cross A bar is positive, if the resultant of a curl is a positive vector, that is positive along any direction, then it is anti-clockwise, that is the vector is rotating in anti-clockwise direction. Similarly, if the resultant of curl is negative, then it is rotating in clockwise direction. Similarly, the most important point is if the resultant of curl is 0, then the vector is either rotating and it is not rotating, so it is called as irrotational vector. Because curl represents the angular velocity or rotation. So now when curl is equal to 0, it is not rotating, so it is called as irrotational vector. Okay, so this is very important point. So if the curl of the vector is 0, then that vector is called as irrotational vector. Okay, so the next concept is Laplacian operator. So if V is a scalar quantity, then divergence of gradient of V is called Laplacian of the scalar V, Laplacian of V. Okay, so that is divergent del dot del V is called and is given by del square V is called as Laplacian operator. So this is the representation of Laplacian operator, and its formula is given by, generalized formula is given by del square V is equal to 1 by h1 h2 h3 of dou by dou u1 of h2 h3 by h1 into dou v by dou u1 plus dou by dou u2 of h1 h3 divided by h2 into dou v by dou u2 plus dou by dou u3 of h1 h2 by h3 dou v by dou u3. Okay, so this is the generalized formula for Laplacian operator. So if you apply it for Cartesian coordinate system, so what you will get is since h1 h2 h3 all are equal to 1, so del square V is equal to dou square V, so you will get dou square V by dou x square. So why dou square V by dou x square? Dou by dou x of dou V by dou x you will get. So all these are ones, so dou by dou x of dou V by dou x will become dou square V by dou x square. Similarly, dou square V by dou y square plus dou square V by dou z square. So this is the formula for Laplacian operator in Cartesian coordinate system. Similarly, if you apply the formula for cylindrical coordinate system, del square V is given by 1 by rho of dou by dou rho of rho into dou V by dou rho plus dou by dou phi of what you'll get, so h1 h3 both are 1 and h2 is rho, so you'll get 1 by rho dou V by dou phi plus dou by dou z of rho dou V by dou z. Okay, so this is the formula. So you just apply h1, h2, h3 is equal to 1, rho and 1 respectively, and u1, u2, u3 are rho, phi and z respectively. Similarly, if you apply this formula for spherical coordinate system, so you'll get 1 by r square sine theta into dou by dou r of r square sine theta into dou v by dou r plus dou by dou theta of sine theta into dou v by dou theta. So here r is there and here r sine theta. So here r sine theta is there and here r is there. So r gets cancelled. So you'll get sine theta. Dou v by dou theta plus dou by dou phi of 1 by sine theta into dou v by dou phi. Okay, so instead of remembering all these complex formulas, you can remember this formula in simple and you can apply anywhere at any time. Okay, so this is the advantage of considering the common coordinate system for vector differentiation. So all the four operators like gradient, divergent, curl and also Laplacian operator, I have given you the common formula where you can apply that common formula for all the three coordinate systems. Okay, so this is about vector differentiation, and in the next class we'll learn about vector integration. Okay, thank you.